Activity 2.2 is called responding output. Now, activity 2.1 is the input, so you're pushing a button, you're doing something, and then you're seeing a message or a value on the microbit. This is going to be just the opposite as far as an output goes. There's your essential questions. As always, you can write those down in your notes. Make sure you answer those throughout. I don't have this I/O device images sheet. I have everything else, and it's all in the back of the room. So when you need something for 2.2, just walk back and grab it whenever you need. Here's some different hex files that you'll want to download. They are code that's already created or set up for you with some basic projects. So what I would recommend doing is download all of these, save them to your Google Drive, and then when you're ready to import, it's a real quick, easy, click on your projects, you click import file and find it from your Google Drive. Very easy thing to do. What is an output? Now we've already talked about inputs. You've looked at some sensors and actuators. There's some questions that you need to answer, what the different pieces are and what they do. And then once you get down here, it's going to take you through some of the different roles for pair programming. Activity 2.1, you watched a couple of videos that walked you through this. This will be really important. What I like to think about this is like a car. The person who's driving is the one who is in control of the code. They're the ones with the hands on the keyboard. They're controlling the tablet. If you have a tablet hooked up for some reason, they transfer the code to the microbit and so forth. The navigator is the helper. They keep hands off the computer. They review the code. They identify any errors, or they can propose ideas. Hey, I think this would work better. Let's try this instead. They connect the wires to the external hardwire or their devices. And remember, these jobs you're going to switch. You might agree on maybe 5 minutes and then switch jobs, maybe 10 minutes, maybe different sections and then switch, but you do want to get practice doing both the driver and the navigator. This is going to take you through some more, and you understand some of this already if you've got to 2.2. Just a quick reminder, the 3V and ground pin should never be directly connected. You cannot take an alligator clip from 3V and directly go to ground. It creates a short circuit and it actually fries the processor in the microbit. So please be careful with that. First step you're going to do, the driver, import that file that you've already downloaded. And you're going to go through the steps, which you all know how to do. Here's what the navigator does. The navigator is going to hook everything up. Now the first one is just a very basic LED. You have a black wire, yellow wire. The colors, again, do not matter as far as the alligator clips go. The pin placement, that does matter. There's also a positive, there's a negative, so if it doesn't work right away, you may have to flip which side you have those on. It's, again, just going to take you through asking you questions, work with your partner, and here we go. Here's the bottom of the microbit. There's pin 0, pin 1, pin 2, 3V, and ground. And there's a way, we don't have access or capability for it, but there's actually 21 different inputs as far as the pin numbers go. We only are going to use these three mainly. You will use 3V quite often, but the main ones you're going to program would be right here. Here's your LED board. You download this. Hopefully you already did that. You're going to import it, and then you're going to test it out. Here's what you need. What's really neat about this is it's broken down into sections. So here's the navigator. Navigator goes and grabs 7 alligator clips, LED board, and you're going to start to test it out. Now this diagram gets pretty long and a little bit tricky, so really break it down as far as, okay, here's your pin 0, your pin 1, your pin 2, and there's your ground. Colors do not matter. There's your conductive thread, which is in the back of the room, and then it's going to connect to your LED board. Now you do need to do some troubleshooting. If it's not working, maybe 2 lights turn on and 1 doesn't for some reason, or 3 turn on and 1 doesn't, you need to test this out. Is everything connected correctly? So trace it back. Start from your board and work your way back up to here. Is everything connected correctly? And you can even try different wires. You can try a different thread if you need to. You just have to troubleshoot. And it's going to walk you through. Connect pin 0 to this, connect 1 to this, connect 2, and so forth. There's your LED board right there. This is your conductive thread. Now it's just to show you that you don't have to have an input connected to it. You can use the thread. The neat thing with the thread is you can hook up a bunch of these alligator clips and they're all basically sending the power between them or amongst them. And you get down here, it's going to show you to download this, press button A. What happens? Does anything happen? You're going to want to type your responses there. What's in a pause? We've looked at this before. 1,000 milliseconds is equal to 1 second. So there might be a time where you have to create that pause in order for it to be able to be seen or read on the microbit. Here's the next file. Download that. If you already downloaded them, you're just going to go to import right away. Here's your buzzer. Now a reminder, the buzzer is not very loud. So if you hook that up, you may have to actually hold the buzzer right up to your ear so you can hear it. Or you can use your headphones. Unplug your headphones from your computer and then hook up one alligator clip to the top part of where you plug the phone or the headphone jack into the computer, and then plug the other alligator clip right below it. And you can test that out as well. Here's what the buzzer looks like. If you don't want to use the buzzer, just replace it with the jack that the headphones are using to get plugged into your computer. There's the next text file, modify the beats. This is for people that are really good with music or really enjoy music. Try to go through and have some fun with this music section. I personally don't know much about music as far as how to create the music, but it's still kind of fun just to play around with. Go ahead and get into, let's say this one. I'm going to click on music. I'm going to try to find something that I can put, maybe tempo. I don't know what that is. Here we go. It's going to tell you exactly what it does. You can play around with that as well. Here's your next file, and you're just testing this out. The standard servo and a continuous servo are two different types of servo. A standard servo, it's going to show you exactly how far the standard goes. The single horn, it's going to show you, okay, here's what that looks like. Now the easiest way to hook into here, it's going to, if you click on it right there, you can blow it up a little bit, is right there. So what you're actually using is you're using jumper wires in there, and the jumper wires are located in the back of the room like everything else is. And these pictures are fabulous. They do a wonderful job of showing you exactly what you should be able to see and do. The servo has a capability of moving a range of 180 degrees, where 90 degrees is the midpoint. The standard servo only goes half circle. And then your continuous servo is going to go a complete circle, 360 degrees around. It shows you exactly what it should do. Now when you create the code, you should be able to stop this, and you should be able to make it go the opposite direction. And it will walk you through that as well. Working with servos, and it's going to just tell you a little bit more information about how they can work, how this can connect here. It's all about transferring the power. So if I have this here, and I'm pulling power from the batteries, it's sending it here, it's going to send it to the servo. It's going to read the information from here, and what you're doing is you're taking your microbit and you're sending out a signal to your output, which is right there. It's going to keep walking you through what to do for the continuous servo and how to do that. Using inputs to control outputs. This is a big section here where you're going to get to kind of play around with what you've done before with Activity 2.1 and then what you just learned from Activity 2.2. Here's the different items and materials you're going to need. Make sure you grab all of that, and if you need something else, just come on back and grab whatever else you need. The more items you hook up, potentially it can be a bigger and better project that way. One thing you have to make sure of when you do this thread, that you do connect it correctly. Conductive thread not. Otherwise it will just slip right out. And that's what it looks like right there. Here's the microbit. Here's where the kind of the back side of that looks like. Here's your debugging steps. As I've said numerous times, debugging is crucial especially when you get into more complex problems or projects like the one you're working on right now. There's your LED blink code. Get your LEDs connected. There's a little bit of code right here. What is that doing? Debugging steps again. I mean, they keep showing the same type of steps. So what this looks like is it's kind of just a big circle. If testing outcomes, if I corner the bug, I isolate it, I crush the bug. If it's not crushed, I'm going to go back and just keep going. There's your conclusion questions. Make sure you write down any answers there. You can also make sure you go and answer your conclusion question that you have to hand in. All right, thank you.